reactive capacity, summary, and managerial insights. News vendors make to stock is a system where we commit to entire supply before updated demand information is received. So we then have supply demand mismatch and the related cost, right? Either due to leftover inventory or lost sales. The key advantage of a make to stock, which is the other extreme of possibilities, right, is producing, right, only after the order is received, right? The advantage is elimination of leftover inventory and avoiding even the lost sales, often, most of the lost sales. However, problems of mismatch still remain. For example, now we have a mismatch due to idle capacity because we have to control the waiting time. So there will be a mismatch in process capacity that produces the products and delivers them or procures them. Either has to be higher capacity than the demand. Reactive capacity is an intermediate solution, somewhere in between these two extremes, make to stock or make to order, right? And this is a solution that can substantially reduce, but not completely eliminate, the mismatch cost. In the case when we had unlimited reactive capacity that had an additional cost for the second order opportunity, right? We reduce significantly the mismatch cost, but we could, and actually we could avoid completely the lost sales, but we couldn't avoid leftover inventory. We could still have some smaller, but still not zero, expected leftover inventory. And the second example, we saw a limited reactive capacity, and we saw that a firm must be able to prioritize its products, right? Roughly, we should produce products first with those products that have low mismatch cost and delay products with higher mismatch cost. In our case, we actually consider mismatch cost per quantity, so per unit ordered, right? And we delayed products with a higher ratio until more information is available about the demand. A successful example of a make-to-order system is Dell. Dell is a company that makes PCs and other products, and some of those products, originally all, but now some of those products are made in a make-to-order fashion. And it shows how this make-to-order approach is particularly well suited for PCs. The reason for it to be so successful is that if you hold finished products, they're very expensive to hold. They suffer from very high obsolescence cost, right? If you have a finished PC today that you sell for $1,000 in a month or a few months, you might have to discount it by a significant fraction in order to be able to sell it. Right? The reason for that is, for example, that component prices are constantly falling, new improved components are introduced, and because of this, you have to discount the older components or the PCs that use older components. Also, labor is a small fraction of the total cost. The reason for that is right, the assembly labor. The reason for it is because the design of computers is modular, so it is fast and easy to assemble them. Another reason is that customers are willing to wait, but as long as they receive a highly customized product to their need at a very low, reasonable at least price. Another reason is there is a lot of customers who are well educated, right, who can configure, can design this variant of the product that they want to purchase, and right, they can do this without seeing the product, right? For example, over internet, they can just select parts and say, just send me this computer. And finally, cost of delivery for PCs is reasonable relative to the cost of the product. It's still expensive, but the products themselves are expensive. So it is reasonable to ship PCs. The cost is not going to be increased a lot, right? However, this make-to-order system is not ideal because, for example, Dell can experience a very high variability of demand. And because of this, if it doesn't have sufficient capacity, the waiting times might be increased. So, for example, imagine that you order a PC from Dell and maybe shipping delay is just 2 days, but production delay from the moment you order to the moment the the PC is assembled, it might take 10 or 20 days, and you might then be concerned with a very long waiting time, and you might actually decide to cancel the order. So there are problems with this approach. An example of reactive capacity, a successful example, is Zara. Zara is a company that specializes in what we call fast fashion or fashion on demand. They produce clothing, accessories, shoes, swimwear, beauty, and perfume products utilizing reactive capacity. They are able to constantly introduce new styles to better match assortment to the trends or tastes of customers. Specifically, Zara owns their own production capacity in Spain. They actually have excess sewing capacity, so that, right, which is underutilized, but thanks to this, it can respond very quickly to demand. If there is a sudden need to produce a larger quantity of products, Zara has the capacity, right? But in order to be able to produce those products, they also have to hold a large inventory of fabrics that are used to produce those products. So if there are some products with long lead time that maybe are imported from overseas, then they have to actually invest in holding this inventory. So they actually have this cost. Still, Zara is very successful in what they are doing, and it has created a significant niche for itself. Customers recognize it for its uniqueness. While Zara actually operates a vertically integrated system in a sense that it owns both stores and distribution and production capacity, some companies also try to operate in this reactive fashion by cooperating with suppliers who produce products for them, and with retailers who maybe communicate the demand trends to the companies that want to operate in more reactive fashion.